Assalamu alaikum, my dear student. Today our topic is conservation theorem for the angular momentum of particles. Means if angular momentum is conserves, mean constant, then we say that the conservations of angular momentums. First, to understand who is discovers angular momentums in conservation's law. Means when adding the discoveries of Newton and Descartes together, we get the law of conservation of momentum. Means after the Newtons and Descartes together, we get the law of conservation of angular momentum. First, to understand angular momentums, and after finding the angular momentums, then we observe the angular momentum conserve or not. If angular momentum conserves, then we say that the conservations of angular momentums hold. First, to understand angular momentums L of particles with respect to an origin from which the position vector r is measured is a defining topic. For examples, this is origin in circles, this is normals upward, and this is position vector r, and this is meeting with normals. This is called M. And position and momentums meeting at a point is known as angular momentums. This is origins. Means L is equal to R cross P is known as angular momentum. Is known as angular momentums. Now differentiations of angular momentums with respect to times means two particle given, for example position and momentum. Now we take derivative of angular momentums. Means if r and p, r cross p given, then we first considered p is constant and take derivative for r, then we considered p for derivatives and r is constant. Means product rules we apply here. For example, derivative of r with respect to t and p considered constant, then derivatives of p r is constant. This is product rules. This is product rules apply here. d r over dt is equal to velocity. Mean derivative of a position is known as velocity, and we know that p is a momentum and momentum is equal to mv. Momentum is equal to mv. And also we know that the rate of change of momentum is known as force. Rate of change of momentum is known as force. Is known as force. Means here we find the torque. What is torque? Torque is a cross product of position and force. Means this is positions and this is force. This is known as torque denoted by tau. Noted by tau. Means this is apply use here. And we also find mv, m cross mv. Mean we take the cross product of v cross v. Means v and v, if we use v cross v, means v and v lie in same plane. For example, v and v lie in same planes, then by using and then by finding cross product between this. Means v and v lie in same planes, then finding cross product between them. We know that the v cross v is equal to v squares sine theta n, and means v and v lie in same plane, means angle is equal to 0. Angle is equal to 0. If we apply v square, angle is equal to 0. This is equal to 0. This is equal to 0. For examples, m is a constant, v cross v, and this is equal to torque, and v cross v is equal to 0. Equal to 0. And by using here we already write Then we write in this way, mean r is 0 we ignore, and tau is equal to rate of change of angular momentum is equal to torque. Rate of change of angular momentums. Short we write. Rate of change of angular momentum is known as torque. Now we discuss now we observe our observations for finding conservation of momentum, and how we find conservation of angular momentum means in the absence of external torque, that is means absence external torque absence means tau is equal to 0. Tau is equal to 0, and we are write in other page, for example this page we use here, means f is tau is equal to 0, for example this dv over dl over dt, tau is equal to 0 in the absence of torque, then v is equal to 0, means if derivative of angular momentum is equal to 0, then we know that, for example if we take integrate for only your understanding with respect to t and also dt, this is equal to 0, and write L, mean every derivative of 0 then is equal to constant. This constant means conserves, and that is angular momentum of particles subject to no torque. No torque means is conserves. Okay, understand? Means if this statement of law of conservation of angular momentum, this is statement of law of conservation of angular momentums, means if torque is equal to 0, then L is constant. L is constant means constant. Conserve means torque means conserves. Torque conserves, and this is known as law of conservation of angular momentums. Law of conservation of angular momentums means if we in the absence of torque is equal to 0 and L angular momentum is constant, this is known as law of conservation of angular momentums. Mean L is conserves. L is conserved, right? L is mean constant. Law of conservation of angular momentum. What is the vector quantities? Means angular velocity and angular momentums are vector quantities. Both have magnitude and directions. Means the direction of angular velocity and angular momentums are perpendicular to the plane of rotations. To the plane of rotations. This is angular velocity. This is positions. This is momentums P, and this is L. L is equal to R cross P. Means axis of rotations. Means the angular velocity and angular momentums are perpendicular to the plane of rotation, to the plane of rotation, to the plane of rotations. Means another questions, the angular momentums always we considered conserves. Yes, we always conserves if there is no net force acting, or angular momentum conserves when there is no net torque, means angular momentums conserves when there is no net torque. Means if no net torque exists, then angular momentum is always conserves. Always conserves. Okay, understand?